At this point, I want to spend some time with this velocity. So here are my lines of code in the draw loop where I'm applying the vector of whatever the touch swipe is to set the direction and the speed of that player object. So in a different video, we talked about how we were adjusting that speed and wanting it to basically decrease over time. So one quick thing we can do here, we can just set this decay factor to be something higher. So rather than 0.15, let's go 0.9. And let's refresh on the screencast. So you can see there, I get a faster speed. Now, the downside to working that way is once I make a swipe, my object just keeps going. It's almost like it doesn't have enough friction. And so one of the reasons that's happening is because the way that we are decreasing that speed, it's a linear decay. So we're dropping down by the same amount every single time. And one thing that's going to do is it's going to take a long time to decrease. It's also essentially never going to decrease to zero. So if you think of this as taking 90% of whatever the current speed is and then setting that to the new speed, if we're always taking 90%, 90%, 90%, we're just going to be taking smaller and smaller and smaller increments off of whatever the speed is. So one way that we could get it to slow down in a little bit more sort of like a natural physical way is to use what's called an exponential decay. And so for that, we would need to keep track of the amount of time that the speed decrease is happening over. So I think what I'd like to do to try that is to make a variable that is going to keep track of the time when the last touch ended. And so down here in our touch ended function, I'm going to set that variable, and I'm going to do this using the millis function. So let's pull this up in the P5 reference. So this is a really useful one for dealing with anything involving timing in your sketch. So I'm just doing Command F here and searching for millis. So this is a function that keeps track of the number of milliseconds or thousandths of a second since the sketch started running. So this is almost like a clock that's running in the background all the time, anytime your sketch is running. And we can use it to basically keep track of when something happened along that timeline. So what we can do once we store the time when the last touch ended, we can use that information to create some exponential decay with this decay factor up here on line 50. So what I'm planning to do is basically raise that decay factor to a power based on how long it's been since the last touch ended. So that way we'll get a steeper decrease and we'll actually pretty much get to zero. And to do that, I'm going to use another function, which we should be able to find under math. This is called pow, and this just is the same as raising a number to the power of another number. And so the way this works, I use the function name pow. N is the base and E is the power. So if I wanted to say 2 to the third power, I'd say pow 2 comma 3. So we're going to say pow. And so 0.9 is our base. And our exponent is going to be the difference between the current millis counter and whenever this one ended. So we'll say millis minus touch end time. Oh. For some reason I'm getting an error here. That's strange. All right, so let's save this. Go ahead back to my screencast and refresh. So that's not quite behaving like I expected it to. And I'm thinking maybe instead of using millis, I just want to use seconds. But looking at the reference here, this is a little bit different. So this just gives me the seconds as though I were looking at the clock. So that's going to repeat every minute. And so what I'd rather do instead is take the time in milliseconds and divide it by 1,000. So this will essentially let me count up in seconds from the time that the last touch ended. That still wasn't quite behaving the way that I expected it to, and I realized I needed to initialize that variable that's keeping track of the time that the last touch ended. And so to make this part a little bit clearer, I'm going to add in a local variable. Called second since, and basically that's going to hold this little piece of math right here. This is going to give me how many seconds have taken place since the last touch ended. Then from here, I can start to tweak my decay factor, and I know that this timer logic will automatically make that decay exponentially. So again, I'll get a little bit more naturalistic sort of decline in the motion of that giant orange brain. So that I can tell is better. It's still taking quite a while to slow down. So let's go ahead, let's lower that decay factor a little bit more. So that's much better. And I think I want to just split the difference. So 0.5. So basically what we've set up here is, again, exponential decay. So that means the rate that the speed will be dropping is going to increase over time since the time that the last touch ended.